we're looking closely at a company called Skydio. And as you'll soon see, we really need to completely rethink what aerial observation actually means today. This quote hits the nail on the head and perfectly establishes the real stakes. Palantir helps institutions integrate information. Fuses helps aggregate real-time sensor streams. But Skydio can generate the observation itself. We're looking at an upstream intelligence generator here, not just a hardware manufacturer. Think about it. While other massive tech platforms are built to analyze data that already exists, this infrastructure is designed to physically go out into the world and generate brand new observations. It is quite literally the physicalization of integrated surveillance. So here's our agenda for today. First up, the on-the-flying camera. Then, the integration web. Third, we'll look at the government buyers. Fourth, the autonomous enforcement loop. And finally, we'll wrap up with the future of surveillance. Let's get right into it. Starting off with Section 1, Beyond the Flying Camera, Redefining the Hardware. First things first, we really need to stop using the word drone. I mean it, that word totally obscures the deeper architecture at play here. Under the old definition, a drone was basically a camera-equipped model aircraft, right? It was just a tool to extend a human pilot's eyes. But today, we are dealing with a flying network sensor that physically relocates itself. It's an autonomous mobile sensor endpoint that connects directly to much larger intelligence networks. The absolute game changer here is that by putting perception and navigation directly on board the aircraft, Skydio breaks that historical constraint that aerial observation requires a human pilot. Take the Skydio X10D, their defense and government model. It actually uses onboard AI to perceive its surroundings and make real-time navigation decisions. It can track subjects, generate 3D models on the fly, and even function in GPS-challenged environments. So the technology has evolved from a pilot traveling with a drone to a remote pilot to a system that literally navigates itself. Moving on to Section 2, the integration web, the nervous system of surveillance. To understand just how deeply connected this ecosystem is, we have to ask a pretty startling technical question about modern law enforcement capabilities. Just think about this for a second. Can a police body camera on an officer's chest autonomously launch a drone? The answer is documented right here in the source material, and it reveals an incredible evolution. Through an integration with Axon, an officer can just press a button on their body 4 camera. That digital request routes through a system called Fusus, which can then launch a docked Skydio drone and autonomously route it to the exact coordinates of the officer. Just let that sink in. One sensor in the network can now physically trigger another sensor to move through space. And this brilliantly illustrates how Skydio operates as an infrastructural node. It feeds data into a visually overwhelming web of common operating picture systems. And it's not just Axon. A 911 call going through a computer-aided dispatch system can act as an automated mission destination. Live aerial video can stream directly into systems like Flock OS, right alongside license plate readers and gunshot detectors. Telemetry can flow into DroneSense or Peregrine. The aircraft is simply a data feed continuously pouring into the larger intelligence systems used by these institutions. Let's jump to Section 3, the government buyers deploying the muscle. I really want to pause on this massive figure, $52 million. That represents a March 2026 U.S. Army order for over 2,500 X-10D systems. The dossier notes this is the largest single manufacturer small UAS purchase in Army history. That is a massive signal of the mass distribution of autonomous aerial intelligence at much lower organizational levels. And as we know, historically, technology scaled in military procurement rapidly diffuse into homeland security and public safety markets. Now, looking neutrally at the procurement data, we also see a confirmed multi-year pattern across multiple operational components of Immigration and Customs Enforcement, or ICE, as well as Customs and Border Protection. We're talking hundreds of thousands of dollars spent adopting this architecture. Down at the border, the source material explicitly notes these sensors are used to observe how many people are present, their activity, and their direction of travel. This essentially reduces response times from hours down to just minutes by streaming that data back to ground personnel. Bringing this back to domestic policing, the scale is equally staggering. The Las Vegas Metro Police Department reported over 10,000 active drone missions in 2025 alone, and they're projecting up to 20,000 in 2026. This isn't just some experimental capability anymore. It proves this is now routine, high-volume infrastructure. Cities are launching these drone as first responder programs, where autonomous aerial platforms are dispatched to emergencies before officers even arrive on the scene.
Next up, Section 4, the autonomous enforcement loop, the brain of the operation.
We can literally map out the chain of custody here, step by step. Let's say there's a 911 call or a gunshot alert. That event triggers a software-mediated dispatch. That dispatch then sends an autonomous mobile sensor, the drone, to navigate to the event. The drone then streams live video and coordinates into an integration platform like Fusus, which informs a human decision. Finally, that footage is automatically retained in an evidentiary record, like Axon evidence. It is a continuous, totally interoperable operational environment. But what you should really take away from this is the complex governance issue it creates. This architecture means one single flight creates multiple persistent copies of data across various platforms, and each of those platforms has completely different deletion rules. If an agency deletes a video from the Skydio cloud, well, it might actually still exist in Axon evidence, or on a third-party server, or even in an API webhook log. It's also absolutely vital to note the current boundaries of this ecosystem. We have to report the facts neutrally here. Despite these vast connections across agencies like ICE, the dossier specifically notes that a direct, automated data pipeline from Skydio into systems like Palantir or Immigration OS is not yet established by primary source documentation. It is technically plausible, sure, but as of this research, it remains unconfirmed. Finally, Section 5, the future of surveillance, techno-feudalism. The dossier frames this entire ecosystem through a fascinating concept called institutional vassalage, or techno-feudalism. You see, private firms don't just sell a physical tool anymore. They sell the hardware, the proprietary autonomy software, the fleet management cloud, the API integrations, and the remote operations docs. The whole shebang. And the more of these layers an agency adopts, the harder it is to ever replace them. They fundamentally condition how state authority is operationalized. So the crucial point is this major shift in dependency. The old reality was simply an institution saying, we own Skydio drones. The new reality is our aerial operational workflow runs through Skydio. Institutions no longer just purchase an aircraft. They buy into an inescapable integrated workflow. The private firm hasn't acquired state authority, but the state now relies entirely on the private firm's infrastructure to execute its authority. Ultimately, we are left to ponder this really provocative question based on the dossier's findings. When you combine remote pilots, autonomous navigation, and seamless software integrations, the marginal cost of aerial surveillance absolutely plummets. It transforms from a scarce resource into an always available institutional service. So when sensors can autonomously navigate to any event at any time and integrate instantly with criminal databases and cloud evidence systems, what exactly happens to the future of public space? It's something we all absolutely need to be thinking about as this infrastructure scales. Thanks for joining me on this deep dive explainer, and I'll catch you on the next one.